Hello, in this module we're going to be continuing our discussion with trigonometry, more specifically right triangle trigonometry. So let's begin our discussion here. Okay, so we're going to find the values of the trig functions of acute angles. All right, so what we got here, we have a right triangle, and we have three sides, A, B, and C, and so you probably recognize this formula. C squared equals A squared plus B squared as the Pythagorean Theorem. So that relationship is going to be coming in very handy for us. Now recall acute angles of the initial terminal side, and there's your theta. There's a right angle, A, B, and C, theta. And then we have a similar triangles. So we have A prime, C prime as the purple, and the B prime are the purple triangle sides, and then A, B, and C are the larger sides. All right, so the trig functions of acute angles. Okay, now the function name sine of theta, that's how you say it. The abbreviation is sin theta. Now let me just stop you right here. A lot of people who are dealing with trig functions will write them, because you'll be writing them down all the time, and they get lazy and they'll leave off the thetas. They'll leave off their argument. So basically they'll say sine of theta, but they only write sin. So sin on its own is just sin, and it's not sine of theta. So you have to make sure you put the argument. It's like writing a function of x, like f of x, and don't put the parentheses in the x. So it's like saying just f. If I just say f to you and don't say f of x, if I put an f of x on above your homework and I said, okay, here's f of x, you know, okay, that's a function. But if I put the letter f above your, in the margin above your, beside your name, you're like, oh, that's the grade I made on this homework. So you're like, oh no, it's a function. So a function of x is f of x. So you make sure you put the argument, or it's just the letter f. And sine of theta without the theta is just sin. And the same thing for the remaining 5 trig functions here. So the sine of theta is the value of b over c. And the cosine, the cosine of theta is abbreviated cos of theta, is a over c. And the tangent of theta is b over a. Now you're like, you know, is there a way to remember the yes? And we'll talk about that in a second. Now look at cosecant, and that's abbreviated CSC of theta. So it's c over b. See, there's 6 sides of a triangle, and there's possible 6 ratios that you could have. You could have b over c, c over b. You got a over c, c over a. You can have b over a, you can have a over b. Those are 6 possible ratios that you can compare to sides of a right triangle. And, you know, just look at that. We got six trig functions that we have. And so the remaining 2 is the secant of theta and the cotangent of theta. And all it does, it just relates to sides of a triangle. So let's look at this picture and make it a little bit more clear here. Okay, here's your right triangle. Okay, here's your theta. And that's b is the opposite side, and c is the hypotenuse, and the adjacent side to theta is called the a. So sine of theta is the opposite side over the hypotenuse, also known as b over c, as in the previous slide indicated. The cosine of theta is the adjacent side to the hypotenuse, and so that's a over c. And the tangent of theta is the opposite side to the adjacent side, which is b over a. Now the remaining 3, the cosecant of theta, is the hypotenuse over the opposite, which is c over b. So if you notice here that the cosecant of theta and the sine of theta, those are what we call reciprocal functions, because one is the reciprocal of the other. So sine of theta and the cosecant of theta are reciprocals. Similarly, cosine and secant are reciprocals, because cosine is a over c and secant is c over a. And the tangent of theta is b over a, whereas the cotangent is a over b. And those are reciprocal functions as well. A lot of people are like, well, how do I remember that? Well, a lot of people have these little mnemonic devices to try to remember, and one of them is Sohcahtoa. You may have heard of that one, and it's spelled Sohcahtoa, Sohcahtoa. Now the problem is the spelling of it. How do you spell Sohcahtoa? If you don't know how to spell it, then the mnemonic device doesn't help you at all. But the reason they say Sohcahtoa is because SOH is sine or equals opposite over hypotenuse. Cahtoa, CAH, is cosine adjacent over hypotenuse, and TOA, tangent, is opposite over adjacent. So I've just found that I can use the same Sohcahtoa but make a sentence out of it, and I can remember the sentence better than I can remember how to spell Sohcahtoa. And I think what I came up with is it's like sad old Henry, SOH, sad old Henry couldn't answer his, CAH, teacher's obvious anecdote, TOA. Okay? Sad old Henry couldn't answer his teacher's obvious anecdote. And it's easy to remember that sentence and then just pick off each letter of that, the first letter of each one of those words to spell Sohcahtoa. And then once you spell Sohcahtoa, you've got the relationship there. So sad old Henry couldn't answer his teacher's obvious anecdote. Well, I can just remember how to spell Sohcahtoa. Is that okay? Yeah, that's okay. But it's just you just need a way to remember which one's which. So, but like I said, there's 6 ratios that you can compare one side of a right triangle to another, and that's why there are 6 trig functions. Simple as that. Okay. So let's look at this next example here. We're going to find the value of the trig functions here. Find the value of each of the 6 trig functions based on the theta. So we've got a theta. We've got the adjacent side 1 and the hypotenuse 6. But they don't tell me how long that opposite side of theta is. The height of the triangle, in other words. I need to know that. So what I'm going to do is first use the Pythagorean Theorem. 1 squared, which is 1 leg, plus the opposite side squared, equals 6 squared. And then solving for the opposite side is the square root of 35. And now I have all the sides that I need. Now Sohcahtoa is SOH. So sine of theta is the opposite side, which is the square root of 35, which I just found, over 6, the hypotenuse, Sohcahtoa. And since cosecant is the reciprocal of that one, the cosecant of theta is 6 over the root 35. And probably your next question is, do I need to rationalize the denominator? In pre-calculus, I don't require it because we have bigger fish to fry than having to worry about that. In a college algebra class or something like that, when you don't have as much to do, I do require it in that course. It's just mostly meant for simplification purposes. That's the whole reason of rationalizing the denominator anyway. So I can live with it or without it, but if you do want to rationalize the denominator, it's 6 root 35 over 35. So I didn't bother putting that here. So now what is cosine of theta? Well, it's couldn't answer his, so it's adjacent over hypotenuse. So it's 1/6. Now this is all in relationship where theta is located at. And so since theta is located in the lower left part of the angle, the adjacent side is 1. And that makes secant of theta the reciprocal, which is 6 over 1, which is 6. And then what about tangent theta? Well, that's TOA, so that's opposite over adjacent. And so the opposite, remember, was the square root of 35, which is just under 6. And the adjacent is 1. And so it's the square root of 35 over 1, which is root 35. And then the cotangent is the reciprocal of the tangent, so it's 1 over root 35. And again, you can rationalize the denominator if you wish. Okay, so when you're given a right triangle and you have 2 of the sides, then you can figure out the other. All righty. Now, when people are doing this, they really don't understand why they're doing it. They get these numbers, but they really don't know what's the purpose of getting these numbers and what they really mean. Well, you don't know that yet, but you will find it really soon. The whole purpose of this is being able to figure out what theta is, what that angle is in between there. So right now we made no mention of what is the value, what is the angle measure of theta. We get there, we just haven't got there yet. But that's one of the purposes, the main purpose of doing these trig functions is being able to evaluate theta based on that ratio. And we just haven't got to that point yet. We're just learning the rules right now. So, okay. So that concludes this discussion. If you have any questions on it, you let me know. And you have a good day.